So our next topic is Zener diode. Zener diode, it is a heavily doped PN junction diode which works only in the reverse bias, and its symbol is a triangle, and this triangle part behaves as a P type and this line will behave as a N type. So let's see the IV characteristics of the Zener diode, how it works. So first of all, if you see, as we know that this PN junction diode is like left hand side is P part and right hand side part is N type. In P type we have a holes, right? And in N types we have electron. So when it is connect, and because of P and N, when we join this P and N, there is a production of a depletion layer. So when we connect it in a forward bias direction, so forward bias means P is connected with positive terminal of the battery and N type is connected with a negative terminal of the battery. So when we switch on, so because of this positive connected to P type and negative connected to N type, slowly this region will vanish and current and electron will flow from negative to positive side, and we can say current will flow from positive to negative. So in this way the forward bias works. So here if you see, initially, when you increase the voltage, there is no current because of this depletion layer. But once this depletion layer will vanish, so you can see a shoot in a current. So when you increase a very small amount of voltage, at this voltage you can see that there is a shoot in a current. So this is the first part, that is in forward bias. Now let's see in a reverse bias. Initially, in reverse bias we know that there is a first point. Here we have P and here we have N. Okay. So as you know that in a reverse bias direction, there is a large production of depletion layer. Okay. So for reverse bias means P is connected with negative terminal and N is connected with a positive terminal. Correct. So here we have electrons and here we have holes. Okay. So if you see now, that Zener diode is a heavily doped. Heavily doped means what? So we will increase the concentration of holes here and concentration of electrons in N type. Okay. Now see, due to this increase in P type and N type electrons and holes, so there is a repulsion between positive charge and repulsion between negative charge, due to which the depletion layer will decrease due to repulsion of electron and due to repulsion of positive charges, that is holes. So they will push in such a direction, and because of that there is a decrease in depletion layer. Now we have this part as a depletion layer. Understood? Now see what happens. This DC voltage is variable. So initially if you see that there is a zero voltage and zero current here. Okay. At this point you can see voltage is 0 and current is also 0. Now when you increase voltage around, for example, let's take 0.5 volt, so you can see that there are some minority charges. In the P type there are some electron also, and in N type there are some holes also, that is called minority charge. So slowly this electron will start flowing from P to N, slowly, and as you increase this voltage, so as you know that by Ohm's law V is directly proportional to I, so slowly voltage also increases and current also increases. Now slowly if you increase around the 1 volt and 1.5, slowly if you increase, so voltage also increase and current also, but at a certain point, at a certain voltage, all the minority charges will directly go to the N type, and due to which there is a shoot in a current in a reverse bias, this point. Okay, here you can see that there is a reverse bias action, and this voltage at which current suddenly shoot in opposite direction, that voltage is called VZ. VZ means breakdown breakdown voltage. Clear? So in this way Zener diode works. So we can conclude that when the applied reverse voltage reaches the breakdown voltage Vz of the Zener diode, there is a large change in the current because of heavily doped. But after the breakdown voltage, a large change in the current can be produced by almost insignificant change in reverse bias voltage. So at the end, we can say that now you don't have to change any voltage after the breakdown voltage, and you can see a large amount of current is flowing through Zener diode. Thank you.